next speaker is Megha Arakeri, and it's called STEM, and its title is STEM for All: Inclusive Education Strategies to Bridge the Digital Divide. A really interesting topic. Welcome, Megha. It's an honor to have you here. Um, welcome. The floor is yours.
Thank you. Hello, everyone. Am I audible? Okay. Hello, everyone. I'm Dr. Megha Arakeri and working as professor in computer science and engineering department of Manipal Institute of Technology, Bangalore, India. And I'm happy to be part of this IEEE STEM Summit. And I'm very much excited to share my ideas on my topic, STEM for All, inclusive education strategies to bridge the digital divide. So we'll begin the session with just a minute. So we will begin the session with looking at the current status of STEM education as well as what are the challenges in implementing STEM for all. And then we look at how inclusive STEM ecosystem can address these challenges and implement it successfully with collaborative and outreach models. I will also share some few case studies, interesting case studies where they develop strategies to bridge the digital divide. And we'll wrap up the session with few key takeaways where we understand like what kind of strategies to build, and it helps us envision and contribute towards a sustainable and inclusive STEM education system. So, before beginning with the topic, let me introduce. I'm a professor working in MIT Bangalore, India. I'm from India. I have 22 years of teaching and research experience, and my research domain is in computer engineering and its allied areas. And I am also actively involved in IEEE and currently serving as committee member of EPICS in IEEE and chair of IEEE CS Bangalore section, and I'm also recognized as distinguished speaker by IEEE Computer Society. So that is about me. So coming to the topic, STEM for all. So in today's world, despite advances in technologies, millions of students, especially in rural, low income and underrepresented communities, still lack access to quality STEM education. But STEM education is very much essential for everyone because it drives innovation, job, economical growth. But if only a part of the society participates in STEM, then it widens uh, the equality aspects, it widens inequality as well as the complete participation in STEM and also affects the global progress. Hence, it is necessary for every learner, irrespective of where they stay, who they are, can participate in STEM education and thrive in digital future. So let's look at the current status of STEM education and participation in it. Based on certain global surveys, it is observed that around 3 billion people are still not connected to the internet, and participation of women in STEM is very low, around 35% of STEM graduates. And the connectivity of the internet in rural is very less compared to the urban areas. So what's the reason for this? This is exactly the digital divide. So when I say digital divide, it is about the gap between the individual who has access to digital technologies and opportunities in STEM and those who do not. So when I say digital divide, it's not just about having a computer or not having a computer, but the digital divide has multiple dimensions like access divide, skills divide, and content divide, and gender and socio-economic divide. So, access divide is about unequal access to devices or internet connectivity or digital infrastructures. So, for example, the students in urban may have online STEM labs where the rural students may not have the internet connectivity at all, as well as the skill divide, which talks about the differences in digital literacy. So the students of the urban areas may be exposed to the robotics or the coding or the high-end technology aspects, where the rural students may lack all of that. And also the content divide contributes to this digital divide. That is, most of the STEM learning content, it is it's not available in the regional or the local languages. So with this, it limits the participation of the students who are outside this English speaking community. And also, due to the gender and socio-economic divide, there is less participation of the women, as well as students from the low income category are underrepresented in the STEM education. So, with this, that is the current status of involvement in the STEM education. So, then what are the barriers? So, like what is causing this digital divide? That is, one aspect is infrastructure and access, because if you take the remote regions or the rural regions, there is lack of reliable internet connectivity, lack of sufficient devices for the students. With that, they cannot have access to the digital content. As well as it is about curriculum and pedagogy, where the curriculum designed is maybe at the very abstract level, or it may be irrelevant, or it may not take into consideration the different learning styles of the learner or the student. And also lack of teacher training on the delivery methods, how to design the curriculum, as well as the digital tools. And one of the other barrier is cultural and psychological issues. Where is it like the STEM is for boys, or it's very hard to study the STEM subjects, and most of them use technology as a luxury rather than using it as a tool for learning. And also lack of reliable role models who may serve as a good mentor, or who may serve as a good guide, and also they can be a motivation for the students to participate in STEM. So that was about the barriers of for the involvement of the STEM and the reasons for a digital divide. So in order to overcome all these challenges, so we can have inclusive STEM ecosystem, uh, which can have universal access. That is ensuring that every learner has the device, connectivity to the internet, access to the digital content, and complete participation in the STEM learning. And also it can provide the relevant content. That content which is more relevant to that category of students takes into account different learning styles, as well as has the local content, means it must relate the student to the community problems around him, so that he gets motivated to learn the STEM and understand how the STEM can solve the problems around him. So that becomes the motivation factor for him. And also, mentorship plays a very important role in inclusive STEM ecosystem. That is, assigning the students to mentors with different background. Like we can have like different genders, like we can have women mentors, or the mentors from academicians or the industry expert, so that it enhances the sense of belongingness for the student in the classroom, and also provides them for the role model as a motivation for them to get involved in the STEM. And also it should have the accessible design. Accessible design means taking into consideration the diversity of the learners, and irrespective of their physical needs, disabilities, they should be able to involve in the STEM. So the curriculum design must adopt universal design for learning. That is what I mean by UDL principles. So then we can have the complete curriculum which can address the needs of different types of learners. So this inclusive STEM ecosystem, what I talk now, it cannot be just implemented with the education sector, but it needs a strong collaboration between different sectors of the society, like education, policymakers, or it can be industry and even the NGOs. So they all have to collaboratively work together in order to support for the students in the STEM education. So the education sector here can focus on building up the UDL principle based curriculum design, as well as training its teachers for the delivery methods and on the digital tools, and also looking at how to make the curriculum have the local content, and also look at the performance of the student, understand the issues in why the students are not having the good scores, and try to support the struggling students. And whereas the policymakers like NGOs and governments together can work cooperatively to bring in the policies, like they can help in funding the broadband infrastructure, or they can provide the resources for the rural or the remote regions in order to have the STEM education. And whereas industry and NGOs can collaborate together to donate certain resources to the community for STEM education, or they can mentor the students and also can develop the open source content or the resources for the students. So this is how they can collaboratively work effectively to provide that inclusive STEM ecosystem. So, in addition to that collaboration models, it is also important to adopt these outreach models. So, the outreach models, I mean that reaching the unreached, taking the STEM beyond the classroom, that is, taking it directly to the community. For example, we have the mobile tech labs where the whole set of the equipments like your laptop or the robotic kits, IoT kits are directly taken to the community in order to provide the STEM education. So this overcomes that barrier of access as well as in place infrastructure. And also the other model of public private partnership in order to issue certain bring in certain policies to have the STEM education, and how to provide the facilities and how to involve different users in building the inclusive STEM ecosystem. And the other one is family focused digital literacy. So just providing the literacy to the student is not enough, but also you have to literate digital literate even the family, so that it provides a support system for the student. The home environment gets converted to its support system for his learning of STEM. So the other outreach model, what we can take is we can consider technology as an enable for STEM education. So the technology, there are various kinds of advanced technology as well as features which can make the access to the digital content in a more effective way. For example, the accessibility features, some of the tools we can integrate into the digital content like screen readers or the captions, speech to text or the text to speech features can be introduced into the digital content, so that the content is accessible to every kind of learner. As well as, so in your rural regions as well as the remote regions, we have the low bandwidth connectivity. So in that case, we can have mobile friendly apps which make use of less resources, which may not need the strong connectivity there. And also we can have the preloaded content, like we can have the ebooks or the already recorded video lectures, as well as educational content already loaded into the educational system. So they don't need constant internet connectivity. And advanced technologies like virtual and augmented reality also can be used in order to provide that immersive learning environment. For example, if the lab is very complex and very expensive, then you may not have that facility at all. So that time we can use the VR or the AR technology in order to provide that immersive learning environment for the students. And also we can, if the cost is a barrier, we can go for open source or the affordable hardware components like microcontrollers, Raspberry Pi, or the Arduino for coding, as well as we can make use of open source softwares. So this is how the technology can be integrated into the digital tools or the digital content to help deliver the STEM content in an effective way. So I have here some case studies where they have successfully implemented certain strategies in order to bridge the digital divide. For example, the IBM it started a program called as STEM for Girls in India because it was observed that the participation of the girl student in STEM education was very low due to the gender bias. So they initiated a program called as STEM for Girls in collaboration with the government and certain foundations, and they developed the content for STEM learning as well as career guidance. And it was delivered in a blended mode, as in offline as well as online mode. And the online modules, they use a platform called as OpenPTech platform. So with this strategy, they were able to reach 10 plus Indian states covering large number of schools, and it benefited large number of girl students in India. So that was one of the successful strategies to bring in the STEM for all. And the other case study what I have is lend and learn. So in cases of COVID-19 or the pandemic situation, many of the US school districts, they were not having the sufficient connectivity to the internet or from home, and also the completion rate of the homework was very low. So in that case, a strategy called as device and hotspot lending library was created, where it focused on lending laptops or the tablets or the portable Wi-Fi units to the students. So that the content delivery, what was going on during that pandemic situation, it was in the online mode. So the students were able to get connected to that content and also learn the STEM and also complete their assigned tasks. So those were some successful case studies which utilize different strategies to bring STEM for all. So when we implement that inclusive STEM ecosystem with our collaborative models or the outreach models or the innovative strategies, it is very important to measure the impact, whether the strategy what is built, whether it is effective, whether it is actually doing its job. Like we can have the access matrix in order to uh, check what resources are there actually available for the STEM education. That is there the internet connectivity, what percentage of students have that internet connectivity, or how many teachers are trained with those delivery techniques or UDL principles, or the number of devices distributed. And when these resources are in place, what outcome or that strategy gave us, that is, we can track like how many students enrolled in the STEM courses, what was the retention rate, how are they performing, what were their test scores. So this will give us what was the outcome of bringing in those resources or the strategy in place. And with this we will know whether the strategy was successful or we should adopt it further, or we had to think of another strategy in order to build that inclusive STEM ecosystem. And also the plan, the resources deployment may have the long term impact, like it may build the confidence or the motivation in the students to get involved in the STEM education, and also the sense of belongingness. It may enhance that sense of belongingness in the classroom, and also it may enhance the career aspirations for the students. So that all that data may give us the long term impact, what those resources or what those strategies can create among the student community. So here I have with this collaborative models and the outreach models and the strategies what can be implemented to bridge the digital divide. So here I have certain key takeaways for the educators, policymakers, as well as volunteers. So as educators, they should focus on building a effective curriculum which has the relevant content as well as the local content. It should get connected to the community problems so that the student can understand, if they study STEM, what kind of help they gain from them, what kind of problems they can solve around them, how technology can be a way for them to solve the problem, as well as it should take into consideration different type of learners, like different learning styles and the physical needs of the learner. As a policy makers, we should have a strong collaborations between the public and private partnerships to bring in certain policies, and also can mandate accessibility to digital tools and fund certain infrastructure, share resources. So this creates a sustainable resources pipeline for the STEM education, this collaboration between the public and the private sectors. And also, the industries or the volunteers can help us in mentoring the STEM students, conduct several training programs on in the advancement of technologies, workshops for the students, as well as create the open source content for the students. And they can also donate, like NGOs can donate certain resources for the STEM facilities in rural or remote regions. So that those are some of the takeaways. So with this, I would call for action, because the STEM for all, it's not a local problem, it's everywhere, it's a global challenge. So at once we may not be able to solve the global challenge, so we have to look at the community around us and what problems it has. So if we can address those specific needs, and then in turn we'll be able to address the global challenge. So we can at least empower one of the learner in STEM, and visit the schools around us, like the rural schools, help us developing the syllabus for the technological advancement, the syllabus or the lesson plans for the teachers as well as for the students, and how to adopt those UDL principles into the lesson plans or in the curriculum design that can be trained. And also we can use the open source tools, or IEEE also provides various resources like IEEE Try Engineering provides STEM lesson plans, which can be used by the educators to deliver those engineering concepts. So with this, they can these kind of lesson plans help them to improve their critical thinking, design process. All those core STEM skills will be improved with this. And also Epics in IEEE, which is the initiative of IEEE. So that committee also provides the funds as well as mentorship to the students in order to implement the project that solves the community problems. So by involving in such projects, helps them to apply the skills what they have learned in their classrooms, and also enhance their technical skills. So also we have the IEEE Voluntary STEM portal, where it serves as a central hub where the volunteers contribute programs, best practices, resources on how to conduct outreach programs. And there are several articles are also published through IEEE Spark in order to motivate the pre-university students by showcasing how real world applications of the technology, how the technology can be helpful for them in advancing. So, with this, I would like to conclude my talk with a statement of inclusion in STEM isn't charity. It's how we future-proof humanity, because STEM for all is very much necessary. Because the global challenges like climate change or the health crisis, we cannot just solve it. It needs a lot of talent pool, lot of innovations. So if only a portion of the society participates in STEM, then we are not going to meet those challenges. We'll not be able to solve those global challenges. So we need STEM for all. We want everyone to participate in STEM. Diversity, inclusion, equity must be brought into STEM by adopting various strategies into STEM education in order to build that inclusive STEM ecosystem. So in turn, we ourselves are building the robust future ready world around us. So that was my talk on STEM for all and how we can use various education strategies to bridge the digital divide. So thank you. I thank all the organizers of IEEE STEM Summit for giving me the opportunity to share my topic here with the audience. And also I thank all the participants for taking part in this IEEE STEM Summit. You can get connected with me on the LinkedIn as well as on the email. I have involved myself in various outreach STEM education activities. I have developed the content for the schools, even for the teachers as well as for the students on computational intelligence techniques. Since I'm a faculty in computer science and engineering, I have developed the curriculum for rural schools on computational intelligence and also the delivery methods. And I've also brought in several women empowerment techniques on how to bring in the STEM education into the rural women, as well as mentorship program also we designed to provide the STEM education to underrepresented community. So you can get connected to me in order to develop more strategies for the inclusive STEM education. Thank you. Any questions? Let me know.
Megha, we do have one question that we have time for. So, Dr. Megha, how can we make STEM education more accessible in rural areas with limited internet and devices?
Okay, I think I brought in this point because there are we can have like mobile friendly apps. We can design certain mobile friendly apps where they don't take a strong internet connectivity. They can work on, they can handle the data very effectively. Optimal utilization of the resources will be there. And also we can have preloaded content like the ebooks or the video lectures. We can upload into that, and even in the offline mode that can be delivered to the students.
Great, thank you very much. I think I have maybe one more question that I saw on here that we have time for. I'm going to show that on stage. How can AI and open source platforms be utilized to support remote and personalized learning and STEM education?
Okay, AI tools will be definitely helpful because open source platform should be used whenever there is a cost barrier, and also it will provide a lot of tools for the education, lot of interesting tools for the students based on their learning abilities, like different, what are their different needs, by understanding that, because that is what is the AI platform. It takes into account our parameters and accordingly customizes the content that is delivered to the students. So that will be definitely helpful in bringing in the AI to STEM education.
Great, thank you. I think that is all we have time for today. Megha, I thank you for such an engaging and interesting presentation. I appreciate you being part of our event. And I'm going to have you go off stage and stop sharing your slides so that we could share a couple of things with our participants before the next session.
Okay, thank you. Thank you for giving me the opportunity to share my ideas here.